Today I am here at the Center for Wind Energy Technology with Dr. S. Gomathinayagam, the Executive Director. Sir, thank you for talking to Panchabuta.
Thank you.
Can you please tell us a little bit about CWET and your vision as the Executive Director?
CWET is for Center for Wind Energy Technology. It is an autonomous organization under the Ministry of New and Renewable Energy, Government of India, which is probably the only ministry in the world dealing with exclusively renewable energy technologies. And we do the service for the industry, and we are in between the industry and the government policy implementation. And we have the testing, design evaluation, wind resource siting and feasibility reports, DPR preparation, and several other services that is required for all the stakeholders in the wind power development in the country.
As the sector grows and evolves in India from individual to larger captive and IPP customers, what kind of services does CWET provide to stakeholders?
Yeah, the sector is growing rapidly, and CWET has got several services. It will start with the feasibility report and feasibility analysis of a wind farming project, and to which CWET does tender evaluation, technical specification drafting, and wind resource potential assessment, micro siting of wind turbines in a given wind farm area, and also the complete techno-economic analysis of a wind farm development for any IPP or any public sector other undertakings we do. CWET also offers power quality measurements of wind turbines in the field, and also acoustic noise measurement as per the International Electrotechnical Commission norms. This we have done for several industry, and in the international collaboration, CWET has got collaboration with several countries, National Renewable Energy Laboratory, USA for 5 years, and Denmark and Scottish Development International for offshore wind power development, and we have collaboration with Sweden for training manpower for the developing world, and CWET itself for the national program. We conduct every year 2 national training programs for all the stakeholders, which are attended by many number from industry, bankers, financiers, and academicians, researchers, and so on. And CWET is also offering specialized training programs for African countries where the developing market for wind energy is there. And we are conducting Ministry of External Affairs, ITEC, International Techno-Economic Cooperation Project, funded project. Every year we are conducting 3 weeks intensive training program for wind energy technology applications. We have trained over 300 people from some 33 countries in the world, and this we hope to increase it as customized training in specific areas of wind energy.
With the growth of the sector, what kind of opportunities and challenges do you see for CWET?
CWET has been able to live up to the expectations as an ISO organization with the quality systems in place for all the services, including consultancy and sponsored research and research coordination with other institutions and everything in time. But still, since the industry is in dearth of manpower, we lose the trained manpower, skilled people from CWET to the industry. But we take a long time to train people who are coming with the single disciplinary knowledge in the multidisciplinary area of wind energy technology exploitation, and losing manpower on and off gives CWET's quality assured service and accredited service, which are internationally acclaimed. Sustaining such services becomes extremely difficult with a manpower shortage all the time we are facing. We also engage several project assistants for temporarily 2 years on contract basis, and with some kind of in-house training for various services and software and hardware related, and we are able to manage the industry demand to meet most of the deadlines in the time-bound projects.
A number of global manufacturers have established large manufacturing base in India. What do you see as the reason for this?
The biggest reason is that in early 90s, we had wind turbines being delivered in India, but not supported adequately into the O&M, operation maintenance, for lack of factories being in India. And this was very well conceived by the Government of India and the stringent policies of the Government of India to have manufacturing facility for the model which is marketed in India, along with ISO certification for the manufacturing facility. And this has necessitated all the global players in the wind energy sector to set up factories in India. And another biggest reason why they have set up factories in India, I would say, is the large availability of engineering manpower and EPC contractors in India, which will facilitate significant cost reduction to serve the Indian industry.
You have earlier talked about the need for Indian wind industry to focus on research and indigenization. Could you please elaborate?
Yeah, India has no IPR culture in terms of research, and when compared to the gross investment in research and development in India is very low when compared to the research investments which are coming from various industries in other countries. And the reason is that there is no incentive for doing research so easily available, and the business model in India, the manufacturers stick to quick adoption of technology in a WTO region, and it is very clearly seen that most of the designs of wind turbine models which are marketed in India also are coming from abroad, mostly from Europe, with IPRs and stringent manufacturing and supply chain to be retained from Europe and so on. And this has given machines which are having power curves with rated wind speeds of say 10 to 14 meter per second, maximum wind availability in India being somewhere around 6 to 7 meter per second all over the windy regions, while 9 to 10 meter per second wind availability is there in Europe and US and other places, when the designs are suited for that kind of wind speed, whereas the sites in India have 6 to 7 as the most probable wind availability in the windy regions. There is a missing gap. There is the machine design is machine specific power curve, which has peaks in 12 to 14 meter per second, while the site specific wind speed distribution curves, they have peaks in 6 to 7 meter per second. There is a clear gap which is seen. So we need to design India specific designs which will at least bring down these rated wind speeds to from 12 meter per second to somewhere close to 8 to 9 meter per second. That would be giving more annual energy production in the wind sector, and that is the need of the hour. I think that the research for this India specific design must initiate from the industry, otherwise it cannot go from any R&D institution to directly in the commercial. That is what I mean, that there is a indigenization with special reference to India is required.
Can you elaborate on how a consortium based approach to research can help in bringing down cost of wind turbines in India?
Consortium based approach would attempt issues which are coming from the field on components which are not able to function adequately in conditions. This right now the R&D and development and indigenization and improvisation for Indian conditions happens in closed doors in various companies, and one does not share essentially his experience or how he overcome the issue to the others because of commercial reasons and IPR relevance. Even though IPR regime is important for protection of knowledge and knowledge generated and for commercial reasons, the issue and the solutions and the methodology of how they improvised for Indian conditions to make their machines perform better should be shared in a consortium approach. Like what's happening in US, there is a consortium for gear developers. What's happening in US and Europe, there is a consortium for generator and control system power electronics development. So this consortium approach will eliminate problems faced by one person not to be repeated by another person. This is what I mean, consortium based approach with the very conscious decision of protecting IPR of individual this thing, giving a more positive development without cutthroat competition.
So not just can a consortium based approach be possible at the turbine manufacturer level, but at the component level could a consortium be formed? I mean, you are talking about different components and consortium forming at the component level, whether it's gearbox and so on and so forth.
Yeah.
So even the supply chain people could actually get together in India and form a consortium?
Yes, very much. Because the supply chain, if the foreign licensing agency wants to retain the supply chain from Europe, then the cost can never come down. The consortium approach, if every component, if it is really dealt seriously to provide more better product with a lesser cost in India, and the volume business will grow enormously. So this is what will be the very useful thing, the outcome of consortium based development and problem sharing and solution sharing.
It seems like there exists a potential for a public-private partnership-based center for excellence kind of an approach. And if that is the case, what kind of areas would CVET be looking to collaborate?
Yeah, one of the under the PPP mode, there was a proposal to set up a blade testing factory in India under a PPP mode. The work as seen through several slides is not that India is not capable of developing a blade testing capability, but it is the accreditation, which is international accreditation, since most of the accreditation bodies being in Europe, and we wanted to have the PPP mode of collaboration for blade testing facility in India. This is an example in which government was willing to part with 50% of the funding, and the other share has to come from industry as well as the blade testing developer who has got a consortium and accreditation, so that any development of a blade testing facility will be ready with the accreditation, and the testing done will be internationally recognized. So this is what is required in the PPP mode of development, and without PPP mode of development, no research can go to commercial industry. Unless the industry puts in at least little bit of money, they will not be accountable. They will just use the government money to do research, and then they will not be committed to take it down to the earth, that is marketing and commercialize the product. So the PPP mode will definitely facilitate the developed product will be commercialized. CVET has the testing facility now with the international accreditation. It has enable accreditation and 17025 compliance. That has become recognized by all certifying bodies in Europe, and many of the certifying bodies take the test results, test reports, and issue certificates. And CVET has got excellent world-class service in the wind resource and microsighting and feasibility report and due diligence studies and so on. So what we are planning to use as a center of excellence is that CVET should have a recognition by the international bodies that any work that is assigned to CVET and the output will be on comparative basis from any other organization in any elsewhere in the world. And this is the aim with which we are working to deliver things and calculations as accurately with as reliably as possible. And the recent requirement in the wind power is that how to solve infirmity, and wind forecasting and scheduling is going to be mandatory, and in which CVET is yet to step in as a company to offer the service, as I told you, for lack of really manpower, and forecasting is such a tricky job in the case of wind, and that too with a weak grid like in India. The forecasting algorithms which are run by foreign companies, which are based on satellite based remote sensing and so on, if they are not validated by ground truthing, they become very inaccurate. This has been experienced by the 4 or 5 companies which are already offering forecasting in India. In addition, when the scheduling becomes mandatory, CVET would like to be in the forefront to join hands with companies to give regional forecast as well as localized forecast for individual wind farms as a service. This is our intention. This is a long-term goal under which we are having a collaboration with the USA. We are planning one with Spain, and we are already running a forecasting model with Resource Denmark. These experiences will give us strength and power to give most reliable data based on the Indian experience to the scheduling of wind power forecasting in India.
As the Indian wind energy market leads the growth, what kind of platform does it provide to national and international stakeholders?
For IPPs and mega project developers, already CVET has got experience in providing to the public sector. For instance, NTPC, ONGC, IOC, all those public sector undertakings. We have given 50 megawatt, 100 megawatt project prospecting, how to start, where to start, and preparation of DPR and techno-economic analysis of offers by multiple manufacturers. These are some areas where CVET can provide an unbiased service to the industry. And CVET's aim to have center of excellence and opening up to the industry to come to CVET and set up their common laboratories which can be used by all the manufacturers for their component testing or any other solution seeking. We would be very happy to interact with the industry to set up common facilities which can be accessed by anybody, so that without bias a central agency can give you a reliable test report or results or analysis or a due diligence study. This is our ultimate aim. Apart from growing our services to the really needy off-grid applications by using small wind turbine testing, and in the world, I think next to NL USA, National Renewable Energy USA, India has resorted to small wind turbine and small system testing at a cost 1/10 of the expenditure involved, just to benefit small wind industry to come up. And this we would be doing as a service to the nation to get these 40% of the population who are yet to see the light of the day to have a power connection. This is we always stand up with the policies of the government of India, and CVET has also erected 51 stations all over India, solar radiation resource assessment, in which wind sensor is also one of the things. These data will be a low level data which can be highly relied upon, and it is first of its kind in the world, because along with solar radiation we have the meteorological data at a low level, and it is available simultaneously for 51 stations all over India. And a similar project with 75 stations of wind resource monitoring with a 100-meter anemometry is in progress, and we will be getting the data online through a centrally connected server from all these stations soon, in a year or two. The project is already under execution in several states. The towers are in place. Industry's wholehearted participation, without which we cannot deliver things directly for practical use. Whatever is done with computer software and simulation, unless it is practiced, it will not be of any use. So this is the motive with which CVET is working, and we do work and services and develop facilities only what is required by industry in future. This will be short-term certificate courses which will be highly specific because of the multidisciplinary engineering requirements. We will be giving special purpose training programs based on our research and outcome and the expertise and capacity built in CVET. In all our training programs, we make sure the faculty is not only drawn from CVET, we draw the faculty from the hardcore industry, the people who are really executing the job, and this is an added attraction for the training which is given by CVET.
Thank you, Dr. Gomathinayagam.
Thank you.
It's been a pleasure talking to you.
Nice meeting you.
So much.
Thank you very much.